So suppose x1, x2, xm are IID with PDF or by sigma 1 to power alpha gamma alpha e to power minus x by sigma 1 x to power alpha minus 1 x positive sigma 1 positive y1 y2 yn is another sample with PDF 1 by sigma 2 to power alpha. I can choose here different alpha and beta, so sigma 2 to power beta, gamma beta. So here alpha is any positive known. Alpha is known to us. Only quantity unknown is sigma 1. So sigma 2 to power beta, gamma beta, e to power minus y by sigma 2, y to power beta minus 1, y positive, sigma 2 positive, beta positive. So I try to compare the given model with this, with mu1 0 and mu2 0. So what is the joint PDF of x and y? F theta x comma y. So what do you get over here? Sigma 1 to power m alpha. So 1 by gamma alpha to power m gamma beta to power n sigma 1 to power m alpha sigma 2 to power n beta. In fact, I can write down this as product I is equal to 1 to m 1 by sigma 1 to power alpha so I can write down just this as 1 by sigma 1 gamma alpha e to power minus x by sigma 1 x by sigma 1 to power alpha minus 1. Same thing for yi, so product I is equal to 1 to n 1 by sigma 2 gamma beta e to power minus y by sigma 2 y by sigma 2 to power beta minus 1. This would be yi, this would be xi. So I have to see whether this can be written as in this form or not. So sigma 1 to power m can come over here, sigma 2 to power n can come over here. So this is same as 1 upon sigma 1 to power m, sigma 2 to power n, f of, this would be xi, this would be yi. F of x1 by sigma 1, xm by sigma m, y1 by sigma 1, yn by sigma n. Now this is for the case where each xi is positive and each yi is positive. Otherwise the PDF is 0. So again this would be PDF would be 0 if f would be 0 if one of the xi's is negative or one of the yi's is negative. Okay, so when you compare with this, you realize that this is of exactly the same form, because everywhere it depends on xi only through xi by sigma 1, and it depends on yi only through yi by sigma 2. So it is of that type. What I need to do? This is kind of a gamma, so you can see that summation xi and summation yi is a complete sufficient statistic. So So let me call this as xy is complete sufficient. And W was anyway ancillary. So if my loss function is, so estimate, suppose, is sigma 2 by sigma 1 to power b. So first I need to choose what is a estimator, some estimator which is a function of a complete sufficient statistic and is scale invariant. So certainly, because you are interested in sigma 2 upon sigma 1 to power b, expected value of yi is sigma 2. So expected summation yi is m sigma 2. Expected summation xi is m sigma 1, expected summation yi is n sigma 2. So one estimator which you can choose is nothing but summation yi by summation I is equal to 1 to m xi. So this is n sigma 2 n sigma 2 power b. This you can see clearly is scale invariant. Why? Because when you change x and y's to rx and ry, sorry, rx and sy, s comes out over here, r comes out over here because s is common. It becomes s by r to power b times original. So delta naught of r x sy is same as s by r to power b of delta naught of x phi, and that is what the definition of an invariant procedure was in this case. So this is clearly belongs to Dm. W was ancillary, and this is also a function of complete sufficient statistic x phi. So what is the MRI? If I take my loss function a by eta minus 1 whole square. Let us take loss function to be this. So what is MRI? Just now we saw for this loss function, which is Wt minus 1 whole, sorry, Wt as t minus 1 whole square. MRI is expected value under 1, that means sigma is 1 is equal to 1 of delta naught xy. Ideally W would come, but W is ancillary, delta naught is a function of a complete sufficient statistic, so conditional expectation doesn't come. E1 of delta naught square x comma y times delta naught xy. Delta naught is this quantity known to be this, so only thing I need to find out under sigma 1 is equal to 1 and sigma 2 is equal to 1, what is expected value of x by y to power b. So let us try to find out, that means I'll need expected value of this to power b, expected value of this to power 2b. This is x, this is y. So in general I can find out what is expected value of under 1 of x by y to power r. Which is same as expected value under 1 of x to power r into 1 by y to power r. Which is same as expected value, because of independence of the two samples, it is the same as expected value of x to power r into expected value of 1 by y to power r. So here I have assumed that the two samples are mutually independent, so that these x's and y's are independent, so in particular x and y are independent. Now under sigma 1 is equal to 1, each xi was gamma under sigma 1 is equal to 1, so gamma alpha. So that means under sigma 1 is equal to 1, x has gamma, standardized gamma m alpha. This scale parameter as 1 because sigma 1 is 1. What would be y? n beta. So I can find out this quantity. So in fact, I can find out expected value of x to the power r under 1 is nothing but 0 to infinity t to the power r e to the power minus t. X was gamma m alpha. So t to the power m alpha minus 1 by gamma m alpha dt. This you can combine with this, so that itself becomes a gamma function. So this becomes gamma m alpha plus r divided by gamma m alpha. The condition I'll need is m alpha plus r is greater than 0. So I can find out what is this quantity is, expected value under 1 of x by y to the power r. First, expected value of x to the power r, gamma m alpha plus r by gamma m alpha into. Now that is same as expected value y to the power minus r. So here, except in place of r, minus r would come because y is there, so m alpha would get replaced by n beta. So this is same as gamma of n beta minus r by gamma of n beta. What are the conditions? M alpha plus r is positive, n beta minus r should be positive. So I just need r is equal to 1 divided by r is equal to 2. So delta star x so r is equal to 1. That means gamma m alpha plus 1 divided by gamma m alpha multiplied by gamma n beta minus 1 divided by gamma n beta divided by actually E1 delta naught square x, which is same as E x by y to power square. That means r is equal to 2. I put r is equal to 2 over here. So gamma of m alpha plus 2 by gamma m alpha, gamma n beta minus 2 by gamma n beta, and then delta naught xy, which is nothing but I have taken to be x by y to power r, which is summation I is equal to 1 to m. Right. So this becomes m alpha into m alpha plus 1 divided by m alpha plus 2 into m alpha. This is taken here. Now this is n beta minus 1 comes over here, and then n beta minus 1 and n beta minus 2 comes over here. Now what you need is m alpha plus 1 is positive, n beta minus 1 is positive, m alpha plus 2 is positive, and n beta minus 2 is also positive. That means my m alpha should be greater than minus 1 and beta should be greater than 1. This is always satisfied. There is no issue with this. This is always satisfied because alpha is positive, m is a sample size. So I need that n beta is greater than 1 as well as n beta greater than 2. So I need n is greater than maximum of 1 by beta and 2 by beta. So n should always be greater than 2 by beta. So this is the condition I need. And then delta naught. So what is the so m alpha gets cancelled, n beta 1 minus 1, and there is some issue with this. Let me check. It should be n beta minus 1 into n beta minus 2 gamma n beta minus 2. ठीक है? That becomes n beta. So that is okay. What would be this quantity? This is m alpha only, and denominator becomes m alpha plus 1. So there is a problem with this only. There is nothing. Actually, this becomes m alpha, right? The denominator thing becomes m alpha plus 1 into m alpha, right? And then this is in the denominator, it becomes n beta minus 1 into n beta minus 2, that goes over there, and then this becomes n beta minus 1. So this is okay. So m alpha gets cancelled. I hope I have n beta x into x plus y to power minus r, n beta minus 1 to n beta minus 2. Yeah, so this is same as n beta minus 1 and beta minus 1 get cancelled. So this becomes n beta minus 2 upon m alpha plus 1 times summation xi by summation yi, I is equal to 1 to m, I is equal to 1 to n for r. Now note that in the gamma case, expected value for x bar is sigma 1, expected value y bar is sigma 2. So natural estimator is y bar by x bar to power r. So I write down this everything in terms of y bar, and this same as mx bar. It should be m alpha. So this is okay. I think you can convert this into the sample mean also, writing down summation xi as mx bar and summation yi as n y bar. Sorry, I had to find it for b, right? I had to find. So this is the estimator for summation xi by yi, right? I have taken b to be 1. So I have taken b to be 1. So this is estimator for sigma 2 by sigma 1, right? Otherwise power b would come. Right? You can make the appropriate modifications. So this is one problem. One can have a variation of this problem where now my sigma 1 and sigma 2 are same, and I can take them to be 1, and they are known. So case 2, one way is I can take both to be, so let us take first to be unequal. If I take unequal, then xi plus c1 it would be some transformation, let me ti, so ti would become xi minus ci. So it becomes xi minus mu1 by sigma 1. So if you want, you can take sigma 1 and sigma 2 to be unequal, doesn't matter. So let us look at what should be the group of transformation over here. So this should be again G C1 C2, C1 belongs to R, C2 belongs to R. So this is a situation where you are interested in a probability model where sigma 1 and sigma 2 are known. And your estimand is eta, let us say, difference of the mean, mu2 minus mu1. And what I do is gc1, c2, x comma y is same as x1 plus c1, xm plus c1, y1 plus c2, yn plus c2. X comma y belongs to Rm cross Rn. C1, C2 both are in real line. So what I do? I see what is the distribution of x1 plus c1, xm plus c1. So when I put x1 plus c1, xi plus c1 as yi, xi becomes yi minus ci. So all this becomes yi minus ci, so that means mu1 becomes mu1 plus ci. And similarly for yi's, I put it plus c2, so it becomes, as let us say ti, so ti minus c2 minus mu2, so mu2 becomes mu2 plus c2. So the problem P would be invariant under this group of transformation with induced group of transformations on the parameter space as G bar C1, C2. C1 belongs to R. C2 belongs to R. With G bar C1, C2 as mu1, mu2 as mu1 plus C1, mu2 plus C2. Mu1, mu2 belongs to R square. C1 is in real line, C2 is in real line. Now what is happening over here? Under this group of transformation, because I have to now guess what should be my induced group of transformation on the Xn space. So I see where does my estimate gets transformed to. So under G bar C1, C2, mu2 goes to mu2 plus C2, mu1 goes to mu1 plus C1. So this goes to mu2 minus mu1 plus C2 minus C1. So this suggests that my group of transformations on the Xn space and G tilde C1, C2 A is nothing but, sorry, this will be mu2 minus mu1. This is the original estimate, so A plus C2 minus C1. A belongs to Xn space, which is whole real line. C1 is in R. C2 is in R. I see my loss function to be invariant. So my L mu1, mu2, L theta A should be same as loss in the transform problem. So that means L of mu1 plus C1, mu2 plus C2, and A plus C2 minus C1. So what I do? I choose C2 to be minus mu2 because I have 2 degrees of freedom. So I can choose C2 to be minus mu2 and C1 to be minus mu1. So if my loss is invariant, so this should happen for every C1 in R, C2 in R, mu1 in R, mu2 in R. So this would be same as L of 0, 0. A, C2 I have taken as minus mu2 and C1 as minus mu1, so this becomes A minus mu2 minus mu1. So it is some function of A minus eta, which is mu2 minus mu1. So if L is invariant, it has to be a function of this type, and converse also holds, repeating the same argument. Okay, so now I can consider only non-randomized estimators by choosing my W to be convex in A, which would be a reasonable choice. If I do that, then it is enough to consider only non-randomized invariant estimators. So delta belongs to Di if and only if delta of xy is same as delta of x1 plus c1 xm plus cm, sorry, x1 plus c1 xm plus c1 y1 plus c2 yn plus c2. Sorry, delta of transformed should be same as delta of x1 x2 xm y1 y2 yn plus c2 minus c1. So I can choose c2 to be minus yn and c1 to be minus xn. c2 to be minus yn and c1 to be minus x1, so that will give me delta of x comma y is same as yn minus xm, c2 to be minus yn, so when it goes on the other side it becomes yn, c1 to be minus x1, so it goes on the other side, it becomes yn minus xm, plus delta of x1 minus xm, xm minus 1 minus xm, y1 minus yn, and 0, yn minus 1 minus yn, 0. So c1 to be minus xm, c2 to be minus yn. So this holds. So what does that mean? That gives me yn minus ym minus u times d, where my d vector is the vector of these differences, x1 minus xm, xm minus 1 minus xm, removing this, y1 minus yn and yn minus 1 minus 1. But then I know that this itself is invariant procedure, because when yn goes to yn plus c2, sorry, yn minus xm, and xm goes to xm plus c1, it becomes yn minus xm plus c2 minus c1, which is the property of an invariant. So again, repeating the same argument which we have been doing it so far, I say that delta naught xy is any invariant estimator, then any other invariant estimator can be written as delta naught xy minus u of t. Now, the way we did in the last problem, you can see that this d is ancillary. Here also, by the same log argument, if you take 2 points mu1, mu2 and theta 1, theta 2, you can relate it through g bar of c1 and c2. So any mu1, mu2 and theta 1, theta 2, I can write down mu1, mu2 as how much? Theta 1, sorry, mu1 minus theta 1 plus theta 1, mu2 minus theta 2 plus theta 2. So they are same as g bar c1, c2 of theta 1, theta 2. So g bar acts transitively. So risk is again constant. So the risk of this estimator would be same as if mu1 is 0 and mu2 is 0. Risk is constant. So minimizing constant will be not difficult. So I write down the risk at mu1 is equal to 0, mu2 is equal to 0, I write down expectation. I write down expectation as the expectation of a conditional expectation, repeat the same thing. So I leave it over here. You can complete rest of the thing. It follows exactly on the same lines as it was done for the scale case. Of course, now you can go to the third situation where mu1, mu2, sigma 1, sigma 2 all are unknown. So I find equivalent estimation. And one can talk about invariance. So that is one of the assignment problems. Let me leave that for you so that you can get more insight into invariance. So I would stop over here talking about invariance anymore. Now we'll move to the next topic, which would be the decision theoretic estimation. We'll explain what does that mean in the next lecture. So thank you for your attention today.